Hi, I'm Tom and I talk about code. Welcome back to another Rust programming live stream where I'm building a compiler. Last stream we got pointers kind of working. We can take the address of things, we can dereference things and assign to them, and all of the associated work around that. There's one little problem, pointers on the stack don't work. So I can take the address of a global variable, a variable that's shared across the entire program, but taking the address and writing to the address of something, like a function local variable or an argument seems to be broken. I did a little bit of poking off camera, and I think there's actually a really simple solution here, so we're going to see if that works. If that works, we're going to try and write some programs to write some pixels to a virtual screen, because I've got a virtual screen hooked up to this machine, and it would be fun to write code. Now that we've got pointers, we can do the kind of memory referencing and writing to RAM that we need to deal with a virtual screen, which would be cool. If all of that works, I think it's time to start dealing with expressions in brackets. Things like, x plus 2 times 3, so that we can be clear about order of operations. Currently no brackets. I don't support that. I also don't support multiplication, but that's neither here nor there. We will support multiplication at some point, so this will become more important. Just supporting brackets in general will be cool, and once we support brackets, we will be able to do things like b plus 1 equals 5. We'll be able to set the memory address at b plus 1 to something, instead of just having to set b and then move b. Like, we can dereference an entire expression, because an expression evaluates to a number, and a number we can just treat as a memory address. So that's going to have huge implications for how we write code. It's going to be very important. It's going to be big. Okay, so let's start doing it. Let's jump over to some code. Actually, let's jump over to the machine. This is an example program, and this is the error we saw last stream, right? We're trying to load a word, and so we're trying to load a word. We have a reference to the stack, to a local variable, which is, kind of in our stack frame. We're trying to load a word into the C register from the address in the C register, and yet we get this very strange error. And it turns out that this is because I don't understand my instruction set. This instruction is saying load address 0, right? The lower bits are all 0 from the page 16372, which I assume in hex is this. Let me actually test this real quick. Hex, what's this number? Actually, no, well, it's easier to do it the other way, isn't it? 0x3ff4, 16372. So yeah, so that's this number. So in other words, right, because the way our instruction set works, we have 16-bit registers, so we also use this page, this concept of a page. So you have the lower part of an address and the upper part of an address. Basically, I've got my registers backwards. This is not the first time I made this mistake. It will not be the last time I make this mistake. Let's see if we can fix this really simply. Let's find where we're compiling our dereference, where we have our load instruction. And yeah, so if I change this to C and this to 0 and then do the same thing for load byte, otherwise that will quietly fail at some point in the future when I don't expect it. And then I build. And then I test, sorry. If I make test, everything now passes. Okay, well that was really easy. That was really, really easy. So we can reference and dereference stuff. Let's put a big old check here. Beautiful, beautiful. So let's play around with the virtual screen. Let's see if we can do some fun stuff. Let's have a quick look at what the screen looks like. So let me go back to edit. It should be here. It should be somewhere here. Maybe can I just rebase this? Wait, hold on. I should probably deal with anything I have floating around. Lang source. I guess we can just merge this branch, right? We've done pointers. Lang source deref expressions. Okay, we've got some conflicts. Now, I don't know how this happened. What? What? Block. Head. Wait, how? I don't know what's going on here. I don't know how I've done this. This hopefully won't be too... If these merges are too complicated, I'm just not gonna... I don't understand. Like, these lines really have not changed. Push. Did I fix a bug not, like, in the wrong branch? I'm a little confused. I'm a little confused. Maybe I should have rebased. Anyway. I almost certainly should have rebased. What else have we got? Code gen and resolve. Code gen resolve language. Wait, no. Block code gen resolve. Block. Get local. Okay, yeah, so these are just the changes to make locals have type information, which is kind of weird. Resolve. Yeah, it doesn't like that I've added a function. I don't know. I think I've done something kind of funky to my history, and that's okay. So let's... T. Okay, perfect. I mean, that's a fairly easy merge then. I think context has the hash map that we don't need anymore. No, hold on, we need it there. Block. No, code gen, sorry, has the hash map reference we don't need anymore. Cool. Excellent. Okay, so that was weird. Bobius says, you're no good with Git, you know enough to get yourself in trouble and occasionally out of it. You avoid merging like the plague. Because I'm just one person working on this, I'm trying to keep a very linear Git history. So I probably could have, I should have rebased. Merges are fine. I tend to do merge with fast forward only, but here we've ended up with a merge commit, and that's okay. We're just gonna add everything. Cool. So we have a merge branch. I don't love it, but that's okay. But now if I restart, we have our virtual screen. And I think this is where I diverged. I think I accidentally committed something when I added this. I don't know. Something that made the paths diverge. Or actually, I think there was a merge commit. Once you have merge commits in, like, if you have branch A and branch B has a merge commit that branch A doesn't have, I think that's when you sometimes get messier things. I'm not totally sure. Other than this merge and... Hold on. This merge, and there's another merge. Sorry, hold on, I have to not scroll. That's a different thing. Yeah, this merge. So these two merges, I think that's it. I think those are the only two merges in the whole... the only two merge commits in the whole history. There were other merges, but they just fast forwarded, which is cool, which is pretty cool. Okay, so we've got a virtual screen now. We can do things with this screen. So let's def var, let's call it screen hex c1000. Actually, there's not really much point making it a variable because we need two instructions to load it anyway. So let's load an immediate into M, that is COO, because we can only load 12 bits at a time, three nibbles at a time. Then we have to shift left M by 4. Now we can write things to this screen. So we could say put 1 in B and then store byte B M0. M0B, I think. I think that's what we do. And then we need to say what's our halt? I think this is our halt system A00 build. That didn't build. I made a syntax error. Monitor is not defined. Monitor is not defined. Oh, well, that sucks. where has this gone? I swear this was in... I swear I did this. What's my GitHub username? It's not that, is it? Weird. I've lost a file. Rust simple VM. Hardware. Yeah, weird. History. It really hasn't changed ever. Give me 1 second. Give me 1 second. So I wrote this on a laptop, and I might have just forgotten to git add the file, which would be very funny. Workspace, Rust, simple VM. This is riveting, I know, just bear with me. It's gonna be worth it. It's gonna be worth it for a virtual thing. www. Yeah, okay. It's weird. It's added here and it's pushed here, so I don't know. Everything seems to be as expected except the state of this one file. So I'm just going to do something really jank. And then this is literally the most jank thing I could do. 1921. I'm gonna hard patch. What's my 20.54? I'm literally downloading this off of my laptop so that I can use it. Sometimes you got to go for the jank solution. Sometimes you need the most jank solution possible. All right, so I've got the file in temp, and I can just copy it in. This is what we're doing. This is the level that we're on right now. This is the level of desperation. Because, I don't know, sometimes when you lose a change in Git history, that somehow, like it's on the laptop, it's there, it's there, but somehow through the push and the merge, it has never entered the history here. It's hard as well because I have two remotes, because I have two, maybe I just didn't merge the right thing. Anyway, we're just going to copy it because I know what's going on. This is manual, version control. Monitor is not defined, but now I have a monitor, so I just need to like refresh in such a way. I guess now if I refresh, yeah, cool, we have it. Okay, that was a fun detour. Fixing Git problems the inappropriate way. So we can see this puts a pixel on the screen. Now this is a very fuzzy pixel, okay? This does not have well-defined edges. And that's because pixels are not a square, right? If you ever worked with a CRT, you know, they're fuzzy, they're soft. It's also because I don't understand how canvas scaling works. And this is a 40 by 40 canvas scaled up to something much bigger. So that's cool. So that is writing 1 pixel. Now, we can actually write this pixel, you know, anywhere we want, right? We could have some kind of loop. We could say, so we set up M, we could make a loop, call it loop, and then we could have an exit, call it out, or done. Maybe done's a better word. Okay, so, and actually let's initialize B outside of this loop. Let's also say A0. So we'll count in A. So add immediate A. So add 1 to A. Then we want to test A. Let's load 1600. I think 1600 is 12 bits or less. We'll find out. AC, test if A is greater than or equal to C, then we want to add if PC if A is less than C, then we want to add 4 to the program counter. Otherwise, we jump to add done label. This is confusing because it's kind of like saying if A is less than this, then skip over the next instruction. What we're really saying is if A is greater than or equal to C, then jump to done. Otherwise, write a pixel. So we will, actually we'll add A here, we need to say C here, add 1 to A. Then we want to say B. No, we want to set up an address that we can write to, and we want to write to M plus A. Okay, so let's use C for this. So let's add A to M and store it in C. That makes sense. And then we want to store the value of B in C. Then we want to add 1 to B. And we want to add to A down here as well. Cool. And then we want to jump back to the top of our loop. I think this works. Let's find out. Reset. Run. Okay, invalid. Did it compile? No. Add if PC. Oh, it's because I don't know my own syntax. Add if takes 2 instructions. Okay. That still doesn't work. It does something. Reset. Let's try stepping through this. So M gets set up to our screen offset. That looks good. Then we set up things. If this, we want to jump to 16. We jump too far. We jump a little too far. And we jump too far because this is multiplied by 2, and I always forget that. Now if we run, we get something in the screen. Nice, beautiful. That's a cool pattern. That's nice, that worked well. If we zoom out, it kind of looks okay. If we zoom in, it looks really shit because it's blurry. But this is a real program that writes real stuff to our virtual screen. You missed me doing the canvas. I did the canvas off screen, off stream even. But I might want to set it to nearest neighbor. So I've tried to do that. That's how this is set up. The canvas, there's 2 canvases at play here. There's one that I render to that's 40 by 40, and then that gets copied to this one. Both of them are set to nearest neighbor. It still comes out fuzzy. I don't know. I don't know what to do. I don't know what the problem is here. Anyway, so we can do this with assembly, right? And that's fine. But as you can see, doing this in assembly is a bit fiddly. If you're looking at that and you're like, what the hell did he just do? That is totally fair and understandable. Let's try doing it in code. Let's go into my favorite file, test.code, the kind of dumping ground that I use for random stuff. Let's write a function. Let's write a function called putPixel. It's going to take an offset, and it's going to take a color. Okay, and we're going to have a global as well. We're going to have a global int pointer called screen, which we have to initialize in main. We can't initialize globals here yet. We'll be able to do that one day, but not yet. Screen equals 0xc1000. Okay, and then we want to say put pixel, in the first pixel, put a red pixel, and then that's it. That's what we do. So what put pixel does is we make an int pointer called address. This is screen plus offset. And then we write to the memory address adder the color. And actually, this is a car pointer, not an int pointer, because cars are 1 byte and ints are 2 bytes, and that's going to be different, complicated. You don't do web stuff well enough to know why the canvas is so fuzzy. I don't think anyone understands why canvases are like they are. I don't think anyone in the world is qualified to tell me why my canvas is like this. This should be a valid program, right? This should be a valid program that writes a single red pixel to the screen. Let's see what happens when we try and compile it, because this might actually be the least trivial program that I've ever tried to compile. Bin lang test.code. Okay, so we get an error. Why do we get an error? Expected ASM, that's fine. Expected global, expected if. So we're trying to work out what, we're trying to work out what we're parsing here. It can't work it out, and that's because I have used the wrong character for assignment. Okay, that's better. ASM. So we don't know what's going on here. This line, it struggles to pass. It struggles to pass. Put pixel, that's fine. Expected global. Expected ASM, expected global. That's weird. This has to be a really, really obvious error. This might be a bit more interesting. Like, we expected an end of line. So it's really struggling with this line. Could it be that uppercase identifiers are actually illegal? Is that the case? Put pics here. Oh, wait, hold on. No. It's because I don't have hex literals. What's C1000? 49152. 49152. 49152. Okay, now it's going to compile. Or not, but it's closer. It's closer. Okay, so it still hits this line and it's a little confused. It's still a little confused. I'm going to try making this a lowercase identifier. That's not it. That's good. We'll go back to uppercase. Expected token close at this. So we don't know how to parse this. Void main. So it can't parse this complete function. It can't parse this complete function. Huh. This is the actual error, right? This is the line where this is the most nested thing that's gone wrong. And it's saying that it doesn't understand this function call, which is weird. No, it's not. No, it isn't. So let's say let foo equal. Can I say let void foo equal this? What happens when I compile this now? That's a different error at least. Yes, adder equals. Oh, yes, and that's because I have this stupid thing as well. I need parentheses, and this is why I want to do proper parentheses, because I have to have parentheses around this expression. Out of range. Okay, so this is good. So that resolves the last of our compiler issues. As it turns out, and I forgot this, but I don't actually have a statement for just a free expression, right? So a function can only be called if its value is assigned somewhere, which isn't good. That's a bit of a problem. That's a bit of a problem. So we need to deal with that. We need to actually we'll have an offshoot issue, right? A sub issue. We're gonna have a sub issue, and that is gonna be allow bare expressions. That expressions. Cool. That's good. That's good. We also have another sub issue, which is allow. Oh, we don't even need the word allow. We just need constant. Oh, I guess it's a literal actually. Literal greater than hex f f f, because this requires 2 instructions to compile. So we haven't done it yet. Actually, it requires 3 instructions. Two more than 1 instruction. Let's say greater than 1. Okay, so let's do that then. So when I build this now, we get this panic in the compiler because we are not allowed, because we haven't implemented that yet. Where's that line? Sorry, CodeGen 218. So let's do that. CodeGen 218. Yes. So we just try and shove this into a literal. So this requires more work than what we're doing right now, right? This is the trivial case where it's small enough that this works, but that we can't do that in general. We cannot do that in general. So if I is less than or equal to FFF, then this is okay. This is fine. My god, these are very meaty long lines. They need a bit of love to actually be readable. There we go. That looks nicer. Doesn't that look good? Doesn't that look lovely? Is that indented right? Yeah, it is. Otherwise, if it is a 16-bit number, then we can do... Actually, if it's a 16-bit number and I and 0xf, it is 0. Right? So if the lower 4 bits are 0, then we only need 2 instructions as well. Oh, we need 3, I guess, in this case, but this will make sense in a second, right? If the lower 4 bits are 0, then we make a 12-bit number from I right shift 4. So the top 12 bits, we load that first, then we do an instruction, a resolved unresolved instruction for shift left register C. We shift register C. We shift it left by 4, and we store the result in register C. Nibble.new checked 4. Perfect. Okay, and that's all we need to do. Otherwise, we have to have 4 instructions in this block, because then we have an additional instruction, and that is our add immediate, register C, and a literal 7-bit from I and 0xf. And we have to unwrap that. Okay, beautiful, beautiful. And this works. This is going to work first time. Nibble. Yep, this has to be unwrapped. And again, we can unwrap that safely because we can verify at human writing time that is valid. Same issue here. Perfect, that builds. There's still a problem, but that builds. Will I have hardware projects at some time? Arduino, RPi, ESP32. I would love that. I would love that so much, but I know nothing about hardware. So it would be fun. It would be cool to learn on stream and to learn with people, but it's a big commitment. This isn't every case, actually. So we can have a 12-bit or less number, we can have a 16-bit or less number, but we need one final else here where we say to do number to big, because I don't know what to do in that case. Okay, so now when we build this, it gets closer, but something still happens. The PS2 stuff should count as hardware programming. That's true, that is much more hardware-like, and I do want to write some vector unit assembly code soon. Once I get this compiler stuff a bit more grounded, and because I want to give a talk about this at a local Rust meetup about writing parser combinators and my experience. Maybe my experience writing a compiler, I'm not sure how deep to go. But then yeah, I want to dive back into PS2 stuff because I wanna do well. I want to get it working. Cool. Yes, but Bobius is right, that is very low level. Okay, so what's going on? We're trying to assign from void to void. And that is because we have written our code stupidly because I can't just do this. So let's write, well, first off, allow literals. We can do that. So let's commit that. Did I commit my changes to the... Did I commit this? I can't remember. I didn't. What the hell? Have I somehow added this hardware file to my gitignore or something? Weird. Okay. This file was different, right? Because it didn't work before and now it does. I don't know. Something weird happened here. Something weird happened here. That's okay. That's okay. We're gonna plow forward and not question weird Git stuff too much. Lang source compile. Support int literals greater than. Perfect. Alright, so now let's do this other thing, and this is going to be a bit more complicated. This is going to require a new type of statement, a type of statement which is just an expression. Okay, so this is confusing because we have expressions, but we can also have a statement that is just an expression. And literally in this case, it's, you know, an expression like this, which is just a function call. We could have a statement that's a function call, but I think it's more interesting to allow an expression in general. Like, you could just say x plus 2 on a line, and that would be valid. It wouldn't do anything, but it would be valid. So I don't know. That seems cool. That seems doable. That seems doable. Let's just have a quick look at my list of expressions. It's a literal, it's a variable, it's an address of deref. So, I mean, maybe it is only actually function calls that we care about there. No, let's just make it a whole expression. Honestly, it's easier. That shouldn't be my motivating factor, but let's just do this just in case. Self-expression. Self-expression is very important. It's very, very important. Cool. So, expression, well, statement. And we want this to be the last thing we try and do. Like, we've tried everything. It's not an if statement, it's not a while statement, it's not variable assignment, it's none of this stuff. Then we're like, okay, I give up. Is it an expression? And then we need to write a function to do this, because this has to be wrapped in a function for annoying reasons. We can't just use my map combinator. Okay, so this gives us back stir ast. It gives us back a statement, but a statement that contains an expression. Beautiful. So we're gonna map here. We're gonna map. For one thing, I don't know what's going on there. I need to do a format. I have been a bit bad with my formatting. We're gonna get an expression, and we're gonna map the result into ast statement expression x. And I build this, and it's going to yell at me about something. Statement expression not covered. Okay, actually it doesn't. It actually doesn't. When we compile an expression, all we do is compile the expression, right? And I guess push it to the stack. And I guess we just kind of like forget about whatever's on the stack. So ast statement expression. It's just like this. It's just like this. But instead of popping this out to register A, we're going to pop it out to register 0 and just forget what we just did. Cool. So now what does this look like? Oh my gosh, I have to scroll back through a couple of things. That looks like it builds. So let's pipe this out to our disassembler, and that looks beautiful. And then we're going to copy it and run it in our machine and see what happens. So, oh my god, that works. We set a single pixel. This is beautiful. This is the happiest day of my life. Now the program is about, I don't know, how, like what, 4 times longer just to do that. But I think, honestly, it actually won't get more efficient. It's going to get, well, and this is 4 times longer than the program that set all the pixels. Like once we actually put a loop in here, it's going to get even longer because we have no optimizations. But that's okay, that's okay. So let's say let x equals 0, let in, oh wait, no. We have no multiply. we have no multiplication, so we can't do our like width times y plus x. That's not allowed. That's how do we do multiplication? I mean I can write a soft multiplier, right? I can say mul, and then I can say let int. Yeah, and I need to remember Walrus assignment. Let int I, yeah, loop adding. Okay, so we're while, except, so this is good, right? It's good trying to write more code because this is highlighting that there are actually a few things I don't support, like greater than. While I is greater than 0, so if b is 5, so we're multiplying 3 by 5. So we do 3, 5, 6, 9, 12. Yeah, greater than 0. 5, 4, 3, 2, 1. We don't do the 0th case. We say a equals a plus b, return a. Do I have not less than? No, I don't have not either. Not's harder. Not's harder than any of these other freaking well, not harder, but it's another unary operator, and my unary operators are all bespoke. So let's do this. While x less than 40, while y less than 40. This is good. This is quality. Let actually, wait, I'm gonna do this smarter. While I'm gonna do y on the outside, because then I save operations, okay? So let, we're gonna get a row offset, and that is gonna be multiplying y by 40. Okay? This is so dumb. This is what you do when you're like building your environment from scratch. Now I probably will add hardware multiply and divide. I don't know. Hardware divide's hard though, because what does it mean? What does hardware divide mean when you're like when you have 16-bit registers? But it's like I don't have floating point numbers. Hardware mod, perfect, beautiful. Hardware divide, a little bit trickier. So maybe I do a soft divide. I don't know. Anyway, I'm getting sidetracked because I'm worried that this is too stupid. We're gonna put a pixel. We're gonna put it at RO plus X, and we're just gonna write 1. We're gonna we're gonna paint the screen red. Okay? Does this work? Does this compile? Probably not. No. That is almost certainly because we got a compiler error. Yes. What? Oh, this one's easy. I forgot the stupid semicolons that I have to have after my while statement. Okay, so now we get the expected error, which is we have not implemented less than. And yeah, limitation breeds creativity. I think this is the whole point of this virtual machine, right? It's meant to be a weird limited environment, and I want to throw it out to the world and see if people can write weird jank code that does cool stuff. That's my dream. That's my goal. Okay. So I need to implement some new binary operators, and that goes in CodeGen. Binop. This is actually really easy, right? And in fact, what we should probably do is pull this out into a function. Binop compare, where we'll say, we'll have a out vector, which is a mutable ref to a vec unresolved instruction. We'll have, I think, yeah, we'll have a register, which is going to be a register. We'll have a B, which is going to be a register, and we're going to have an op, which is going to be a test op. Okay, I think that's fine. And then we can unindent this quite a bit, which is cool. I think one more out. Oop. That's fine. Rust format's gonna fix that for us. Okay, so we push a bunch of stuff to this vector, except now we want to make this A, pop to A, pop to B, test A, B. A is the thing on top of the stack, B is the thing next on the stack, A, B, op. And then we use C as the thing that we do the thing with. Beautiful, beautiful. And then we push C to the stack because C has our truthiness. Excellent. Okay, so binop. This is now going to be, we're going to say binop compare. We get a mutable ref to out. And we say register B, register C. And then test op LTE. Excellent. This is it. This is what we do. This is what we do. Now this is super, super simple, right? We don't even need the curly braces. We can actually do it like this. So less than equal, let's do greater than. This. It's still not what we need. Still not what we need. We need less than, right? And I should write good tests for all of these, but I'll do that one day. Okay, not yet implemented, unimplemented, 148. There's something else I don't have yet. And this is good. This is really drawing everything into, Okay, well, we should try and print this out. Just so I know what is actually unimplemented. Args. I don't have assignment to args implemented. And this, you know, like, are your args actually mutable? I don't know, like, they get copied to the stack, so you can really put anything you want there. So let's copy what we have for a local. This should be okay. I don't see any problem with this. So we have our arg index. Now, one thing we should actually do as well is type check this. Okay, so we're gonna let type of, we're gonna grab the expression, and then we'll say if assignable resolve can assign from. So if can assign from, we'll only allow this assignment if we can actually do the assignment. Return error this error from 2. Beautiful, beautiful. That's good. That feels good. Now we've done our type checking, we can continue trying to shove a square peg into a square hole. That's good, that's good. Okay, so compiled expression, append. Now, what do I need? Store word, add immediate. So where do our args actually live? Arg C add signed this. So this is what we want. This is what we want. The address of the arg. Index store word B BP. Okay, so here we use B as our address. So we do this. We do this. B is our base pointer. Index as U8 times 2. Yeah, so we do this subtraction. This subtraction. That's good. We push this. This is a lot of stuff that has to go into one instruction. That's okay. And then we store into B, whatever was in C. Okay, this is good. This is good. It's coming together. I think this is okay. So what happens if I just do this naively right now? Okay, that's fine. What doesn't build? We'll call this index. I should have rebuilt that in here so that I actually get a quick fix list. Type of this needs CTX and scope. And I think we have to borrow the expression out of its box, because I think it comes in a box. Or not. Expected block scope, found block scope. So this is a ref. And actually, I don't think we have this as a box. No, okay, that was as ref. That was right. Here we go. Expected type, found type. Beautiful. Okay, so now what happens? Oh my god. Okay. Whoa. It looks like the error we have is saying we can't assign from an int to an int. So that's kind of funny. It also is entirely on one line. So let's just like pipe this out. Let's pipe this into Vim, into NeoVim. Sorry, by that. That's what I want. Except, what do I want 2 to 1, redirect standard error to standard out. Here we go. Okay. Compiling. This is all on one line. This is just one 6,000 character long line, because we've got all the instructions, which is cool. But the error is type assign from int to int. Now that's very, very funny if you ask me. That's very, very funny. So let's go into Resolve, okay? And let's write a couple of tests. If we're in the test config, we want to make a test module. We want to use we want to use everything from the surrounding module. We want to write some tests. We want to test our canAssign function. We want to see what the hell is going on, okay? Because we should be able to assign, so we should be able to say type int dot canAssign from type int. So let's say type int can assign from type int. Now I think I should be able to say assert, right? Because this should be true. And that appears to be true. And I think I see the problem. Does anyone else see the problem? I forgot to say not. So if we can assign from int to int, then hey, blow up. So that makes sense. Now we actually get a program, so that's cool. That's good news. We don't need to send that to Vi anymore. We can send it on to our disassembler. I need a way to load binary programs directly, but I don't know. I don't mind doing it through this copy and paste step too much. I guess the important thing is that I could also do this disassembly in the actual browser, and that would be a bit simpler. Okay, so let's go back. Nothing happens. Okay. So how big is this program? It's not that big, but it's also pretty big. It is simultaneously not that big and completely overwhelming. So let's step through and see if we can work out what's going on. First off, we don't have any labels, which is a bit of a pain in the ass. Oh, also, we're at the wrong offset. We're at the wrong offset. This needs to be loaded at offset 2. Because we have a global, and globals... we have this weird interconnection. Let's run now. So like the program doesn't crash, which is good. It just also doesn't do anything, which isn't good. Let's step through and see if we can follow anything happening. So see, this is setting up. This is the memory pointer. This is the memory pointer. I mean, look, I can actually set this. I can actually do this. Hold on. and I probably should. If I compile it with this A flag, hold on, I can actually get this with labels, which is good, but I need to define this. So let's say def var local count. So I need to actually count how many locals my functions have, because I should export this automatically, but I don't. 1, 2, 3. So main, this has to be 3. Except it has to be 3 times 2, which is 6. And then we're also going to have multiply, and putpix is going to have one of these too. So I should dump this out when I do it in this format. Putpix also has 2, which means 4. And then we're going to have mol, which is also going to have 2 args, which is... Oh no, hold on, args. Putpix has no args. No local... No, it has one local. Size 2. And then this also has size 2. Okay. Build. Step. This works. But we lose the labels. I actually don't know what happens here. I don't know what... I have this configured. Okay, let me pull this up in a new editor just because, for reasons. Simple VM. Look at, so, what have I got up? ASM, assemble and upload. I step through every line. If the line starts with colon, then it's supposed to treat it as a special line, just like if it starts with a semicolon. So if I put a semicolon here, foobar, this is going to work, right? I can build this. Oh, it's because... Yeah, this is annoying. It's because the labels are removed before we get... It's hard to explain. I need to fix it. I really need to fix it. But, how can I fix this? Program line. So all of the labels have been removed, right? This is a problem. I'm gonna think about this. I'm gonna run to the bathroom really quickly, and then I'll come back and I'll see if I have magically come up with a solution by then. Back in a second. That would at least have something visible temporarily. Doesn't do anything to fix the issue at hand. Yeah. Let me think about this. So what does update code view take, right? Update code view takes the lines after they've been resolved by the preprocessor. Really, I think the way to fix this is to think about the preprocessor. And this is a rabbit hole, right? This is a rabbit hole. But what do we call? We call resolve. Now, if I look at the WASM resolve, it does both passes of the resolution, right? Every line. What I really need is to be able to ask the preprocessor for what was defined. And we get variables. We can actually, well, okay, this is a bigger change than I would need, right? What I would need to do to make this work is we have our preprocessor, right? PP, it has a list of, well, it has a map from string to string for variables that get defined. This includes labels. We would need one track if var is label, and 2 get label from the result. Neither of these things are that hard, right? We could do both of these things, but it's a little bit of a sidetrack. I don't know if it's what I should be focusing on right now, but it would be good. It would save me a lot of hassle in the future, potentially, because we would also get labels for our loops as well, and that's pretty cool. That's pretty cool. As it is, this is pretty much impossible to debug. The fact that we don't have multiplication also makes this very hard to debug. It would just be so good to have this annotation. Anyway. Actually, do you know what I can do? Comments get passed through, so I can say init, I can do this the really janky way, right? I can say main, I can find, these are the while loops. The while loops aren't quite as important, the function labels are more important. So put pix. And then we also are gonna have, wherever this is, while label out. Oh, sorry, I completely missed this. I read from this comment to this comment. I did not see this one, I'm sorry. Thank you, that is a good suggestion. Mul. Function mul. Oh, and then I got rid of the label as well, mul. Okay, build. Now, yeah, we can see where we are. So this is cool. Let's try stepping through this for a bit and see what happens. We set up C here, we put the address of the screen in, which is cool. Set up B, C, we just store some stuff there, right? We store some stuff. Okay, so. So we want to see, yeah, so we're doing our tests here. We jump to, we add 4186. What's 186? Oh no, sorry, that's the jump. That's where we jump to 186. That's where we jump to the exit, right? That's where we jump back to, I guess, main or something, or back to the start of the function. We skip over that. Push C to the stack. This is loading a local. Then we make a function call. Do we? Add C 0PC. That wasn't the right place to jump to. That was one off. And that might actually be because our program offset is is not what I thought. Whoa. Okay. That tab just went absolutely crazy. And I think I lost all of the changes I made there. Cool. Okay. There's more work to do with this debugging experience. This code compiles, which is good, but there is a problem with it. So this can kind of go on my backlog. Their expressions, we did this. We actually achieved this as well. Let's use the same color for the check mark. Perfect. Okay, so let me mark this one. I'll say kinda check with a question mark. Let's do that. Let's think about expressions in brackets, right? Because we did play with a virtual screen. I put some stuff on a virtual screen. I wrote code that did that. Let's try and put stuff in brackets. Actually, no. You know what? I'm gonna do one more thing to try and debug this. I'm gonna copy this file. I'm gonna copy this to fill screen. I'm gonna try one thing. Okay. Let's try and just write one specific pixel, one specific coordinate. Let's make an offset, which is going to be an int pointer. We're going to multiply y by 40, and then we're going to try and put one pixel at that offset, one red pixel there. Okay, we're going to try and do this. Edit. First off, what's our... Hold on. So where do we jump to 18? So this does have an offset of 2. Because our main function starts here. Okay, that's good to know. Then I also need to enable the screen. Okay, run. this puts a pixel. Oh, whoa, 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 whoa! I'm in the wrong spot. I'm in the wrong spot. Ah, I'm on the wrong scene. I keep doing this. I keep doing this. Panic. Okay, so you didn't miss much. You didn't miss much. All I did was rewrite this function to be simpler. All I'm doing is putting one pixel in. Yeah, thank you, Bobius. I am glad I got people ready to scream at me when I do this. It's so easy to do. I need a better setup where I can always see my stream. Okay, so that's interesting. That's very interesting. What if I also I should be adding x to this. So let's try compiling this again. Okay, now we end up somewhere else. Now we end up somewhere wrong, which is also interesting. What if we say y is 0, right? What if we say y is 0? Translation, interesting. So where does this happen? This is a bit easier to step through, okay? This is a bit more approachable. A little bit more approachable. We step over the jump. Oh no, we load C, sorry. Sorry, I need to quickly check my phone just while I'm debugging here, while my brain is stepping through what's going on. We jump down. This is where we multiply, right? So this, by the time we get to PC, 0 PC, so 266 is where we're going to jump out of this function. Cool. Okay, we come back. We come back. 0 BP. Interesting. A push. Oh, I hit run by mistake. Okay, let's step. Oh, when we reset, we set the program counter back to 0, not to the offset. That's a problem. That's also easy to fix. That's also very easy to fix. Get register next stop. Maybe not. Maybe we don't actually do that. Maybe that's in our WASM when we reset m.reset. Yeah, we need to reset the program counter. Okay, we can do that. We can do that. Is this a downside or is this a pro? Eating directly out the pot you cooked in. I mean, I guess it depends. Like, I'm in the middle of winter. My soup and my soups and stews staying really hot for ages. That sounds like a pro to me. That sounds like good news. We're gonna step through this a little bit more slowly. I also need a way to like be able to scroll this so that I can step and see what's executing. So this is trying to multiply some stuff, right? I don't understand this. We would. Oh, I don't show arguments anymore. When you have the pot on your lap, you'd like to not be burned. That's why you get a heat-proof mat. There's like just a silicon thing or something, a lifesaver. I burnt my hand yesterday. I was cleaning my water bottle, my stainless steel water bottle, and so I had it filled with boiling water, and then I tried to move it. I thought it was one of my insulated ones, like one of the ones with 2 layers, but I touched it to pick it up, and then I realized it wasn't insulated, and so I dropped it, and then it spilt hot, like boiling hot water all down my hand. Thankfully, it doesn't seem to have done any damage. It like stung. It still stings a little bit, but it doesn't look red or anything. Like I can, if I get in there and rub it, I can feel that I did something to it, but it isn't a bad burn. It wasn't like it was pretty. It wasn't 100-degree water. It was like 90-degree water. So yeah, I was fine. I was fine. Okay, so add f0. So this is where we're trying to do the multiplication, and I suspect what the result we're getting here is in fact 0. Oh no, 76. 76. Why 40? Okay, so 7. So we want to see. Okay, so we've returned 0 from this function, and that's actually what we want. That's actually what we want. We want 0. So that's the correct answer. I don't know if it's the right answer, but it's the correct answer. I don't know if it's the correct working, but it's the right answer. I guess that's the way to say it. Okay, so we push something to the stack. We push 0 to the stack. That's fine. Colt0, hello, welcome. We are deep in the weeds of debugging this program, which should be drawing pixels to a screen, which is very fun. We drew pixels earlier, and now we're trying to do stuff. So, this should be okay, actually. We've got 2 things pushed to the stack, right? And we're trying to add them together. Now, we called a function in between, but that function should have cleaned up its own stack. I'm nervous, but I think this is okay. I really should visualize the stack. That is actually something I could do. Like, maybe if I can detect in my wrapper when I make function calls, I could show the function local. Actually, no. Because I've got the base pointer, right? The stack pointer, yeah, we can look at the stack pointer relative to the base pointer. That would show locals and anything additional we push. So that would be kind of cool. That would be cool. I need more debug information in general, really. Okay, so we get C. C is a reference to cpop add. Okay, so this is where we're storing a local. Then we go 1. So this is the other argument to put pix. We're about to call a function. We're about to do a function call. Rendering from an octree. That is always hard. That's always hard. I've never done it. I really want to do it one day. That would be a fun stream project as well, like octree rendering. What system are you targeting? What platform are you targeting? Is this... I can't remember what system you were working in, I'm sorry. But yeah, no, octrees are fun. Octrees are fun. Okay, so we're about to do a function call. That's what we're setting up for here. We jump down here. This is where we should actually write the pixel. So we're going to watch our registers really carefully. We load... Okay. Let's see... Yeah, so this is our global. This is our screen offset that we load into C, and that looks correct. That looks very correct. And we push this. 0 sp add. So we add the 2 things on top of the stack together, and then we pop it out. So this is the new address we're trying to write to. Now, what's this? This doesn't look right to me at all. What is this in hex? Oops. FFF4. This is not the correct answer. That's absolutely not the correct answer. Indeed. What did we push to the stack before this? So we push and we push. So we push whatever we loaded into C. But we've already overwritten C. And so then when we step through here, we're going to get an error when we try and write, maybe? Yeah, there it is, FFF4. So what is FFF4? How do we get this number? How do we get this number? This could be incorrect sign extension. That's possible. That's possible. It could also be that I've just done something really dumb. Let's try this. Let's try just writing to X. Let's see what happens. So we're just pairing this back. So that works. That works. X plus Y. I really want to be able to just do this with 1 click in the browser. That works. But we also know that multiplying like 0 and 0, we know this gave us 0. So that's weird. But does this suddenly then not work? See, this makes me think it is stack related, yeah. So something's going wrong with how we're managing the stack. Fun side project returning to using a Python GPU library called Tai-Chi. I haven't heard of this. Man, but yeah, Python GPU. So does it just kind of wrap like making buffers and shaders and stuff? creating a modified jump flooding algorithm for a Voronoi diagram where you're running each pass of jump flooding on a series of octree levels. I don't know what jump flooding is. Jump flooding. Jump flooding algorithm used to construct Voronoi diagrams. That makes sense. ACM 2006. Okay, so we have an NVIDIA texture, undefined color, uniquely colored seed. Each undefined pixel will be filled with a color corresponding to that of the seed pixel. More than once. What does it look like? I need to. I feel like I need a picture of this or a video of this. Comprehend necessary cookies. Get all this stuff out of here. Why do I have to click on this stuff? I hate clicking on stuff. Oh, so you have initially colored points. Oh, I think I misunderstood how that worked. Unless it is a uniquely colored seed. Okay, so you end up with yeah. That makes more sense. Iterative X pixel, Q undefined color, P is colored, Q of P is colored, and Q is colored. Yeah, so this is just a Voronoi diagram. That's how they're defined. That makes sense. This is very logical, but that does make sense to me. That does make sense to me. But I guess just doing it on the GPU is very interesting. Is that like? Yeah, no, that's cool. That's cool. Is that like a fragment thing? Like, is this a fragment shader thing, or like what? Like a compute shader thing? I guess you're doing it once up front on the GPU. You're using the massive parallelism. It's interesting. I can't imagine how you would do this in like batches, right? Like what do those batches look like? Because interesting. But yeah, GPUs would be very good at generating any Voronoi-like structures, right? Where you just have a bunch of, you have like this small set of initial seed values, and then you can just chunk like, regions of a texture or something and fill them in parallel. But very, very good at that. Okay, so something is wrong with our stack management, and that's okay. We'll survive. We will survive for today with a dud stack. Let's try and write, let's do one more thing just to see what happens. Let's try and write a pixel in a later row than the first row. Actually, weirdly, this X doesn't seem to be doing anything. $85. So definitely some stack management issues, definitely some missing tooling from my point of view for how we put things on the stack, and how we visualize the stack in here. I think that would be very important to do. Actually, maybe that's something we can start playing with now. Let's maybe just start having a little mess around with this. Get status. All right. So what happened here? We added freestanding expressions, lang, bare expressions, more binops. We're just shoving commits into main. That's good. Let's just get rid of this terminal quickly. Okay, so what does I'm just gonna stop my recording real quick. I'm trying to keep. Okay, well actually now that's dead. I'm trying to make recordings, but Askinema recordings, so I have all the footage, but only of the actual Kodi stuff, not so much of the web browser stuff. Basing what you're doing with the tree on a paper facet JFA, use a series of progressively bigger images until they get to the goal size. So you generate a small image and then you do that process. Like when you test a pixel in the bigger image, you test what color it is in the smaller image, and then use that like neighbors. Sorry. So if the neighbor is the same color in the smaller image, then it's going to be the same color in the bigger image. But if there's a conflict, then you have to test, right? That sounds interesting. That sounds really interesting to generalize into 3D. I like that a lot. I like that a lot. Yeah, cool. For some reason, when I halt an Eskinema recording that's been running for like an hour, it takes a little while to work out what's going on. Let me just see what's going on. Oh, cool. Actually, I'm gonna jump out. I'm gonna jump out. I'm gonna call it there. Before I fall into a new rabbit hole, I'm gonna say that was a productive stream and call it there. So let's pass the love on to someone with a little raid. Let's see who is doing some cool dev. Building and farming. That looks interesting. Automation of Linux GSM. That looks interesting. Working on game design for a game. That doesn't look quite as interesting for our code-heavy viewers. But I'll try and do some work on this browser and visualization stuff off stream. I think that would be more fun. I think that would be more interesting. Then I can just come back and actually build things on stream. Software and game dev. What is going on? Who's out here? Who's out here? Let's raid this Tripod GG. Let's raid this person. This seems cool. Linuxy stuff. Looks very dorky. I like it. I like it. Notepad++. Let's go. Let's throw some love over this way. Thank you to everyone watching. Thank you for everyone who is watching on YouTube as well. I appreciate you a lot. The YouTube views have been coming in a bit more lately, which is really cool. I see a lot of watch time, which is very, very satisfying. We're going to throw some love over this way. Thank you everyone for tuning in. I will be back with better debugging tools and better visualizations so that we can just fly through this stuff a bit faster very, very soon. All right, I'm Tom, and I'll catch you next time. Bye.